Okay, let's talk about transitions and blending out of a feature, in this case a chamfer. So we have a chamfer on a part that's coming down here. It's built at a certain angle to this main surface, right? So we have a constant chamfer right here. And then that chamfer needs to go away on its way around this corner. Okay, so you always want to try to do these things or build these scenarios in a repeatable, thought out process. Okay, so our end result we want to look like this. Okay, so we know we have a larger radii here, two smaller radii in their chamfer, and then that chamfer blends out on its way around the corner. Okay, there's a few ways to do this, and I would say an old school way is to simply take our original theoreticals and run the basic radii that we want. Okay, and then what do you do Then what do you do next? Well, we need to run these radii until these two tangent lines intersect one another. I mean, that's what I would do. So now we get this, right? So this was a 1 millimeter radii. So we just ran a 1 millimeter radii and then another radii, I don't know what that one is, let's say 5, until they came together. Okay, then we develop a couple blend curves in here, one to control the center, one to control the upper tangent line, and one to control the lower tangent line. Okay, and then we put our blend on. So we've got a transition built around this corner. Problem with it is we see some pinching right here. Okay, and that's gonna call your eye. So if we just turn the model off quickly, you can kind of see how the chamfer does go away and it becomes the blend, but it's just not that good looking. Okay, it seems to get kind of pointed right here. So we might say in this case, well, you made your tangent lines too pointed. Let's fix those tangent lines, and maybe that will fix it. Okay, so we take the same set of surfaces and we repair those tangent lines, get them where we want, and then we put a section across here. And if we look at our section now we have a very long flat section, a tight radii, and a little bit of a lead into this surface. Well, the problem with that is now we've almost got a chamfer and a chamfer, because we're determining our tangent lines separate from our theoretical, and we need to construct a theoretical that can drive, and another word for that is derive, the tangent lines. So tangent lines can't necessarily be built and have them work. They need to be based on a theoretical intersection. So if we can just draw, if we just draw a couple of these in, so maybe we come over here and I've got a little view set up here that I think I can illustrate this pretty good. So if I pull up my painting tools, and again, I now with experience, maybe I can do this a little easier in my mind, but typically I do draw all this stuff out. So we know that we have a certain angle, right? We've got a certain angle right here to our main surface, okay? And that's the chamfer angle. So I need to maintain that chamfer angle over here relative to that same surface. How do I do that? Well, I need to construct a plane right here, okay? And a plane right here, and then we can transfer that angle from here to there, okay? And then once we get that, we can determine where our end point is, okay? And I'll draw this a little, I'll keep drawing this in, and I think it'll come around and make some sense. So we have a fillet that's running down a theoretical right here, right? So this theoretical is driving along. It's a little radius right here. Now that wants to go all the way around this corner, right? And become this radii. Okay. When I say become this radii, it's going to become a part of this whole radii. Okay. And then if we look at this bottom radius, we've got a radii here and a radii here, and we want that to transition all the way around this area and go all the way up until it hits this tangent line. Okay, now its other tangent is going to be right here. All right, and that red tangent right here needs to go all the way around and intersect this tangent. So we want to have a curve that goes from all the way from here all the way to there. Okay, and then if we look at our other fillet, we need a curve that goes all the way from here to here. Now we have a chamfer surface right here. Okay, we're going to create that same chamfer surface right here in space, and that little thin strip is what's going to control our radii. And now the key here is that we're making this chamfer not come up and hit the theoretical intersection. We're making it hit on the radius. Okay, and I'll show you how we'll do that. Okay, so we've got a couple things here. I've got this surface, and I've just simply projected this edge, this fillet edge, up onto that surface. And on this side, I've done the same thing, projected this fillet's edge onto this surface. Okay, that's going to allow me to create a couple of planes so that I can shift this chamfer angle from here in this plane to this plane. Okay, so one thing we need to do is we need to duplicate the chamfer. Okay, next thing we need to do is create a couple of planes. I'll use the 3-point method. This is very important. You need to pick these in the same order so that the chamfer orients correctly. And I'm going to make that order the base point of the tangent, my projected line, and the end of my fillet. Next plane. Okay, we'll move over here to this end. The base point or the tangent, the projected end, and the bottom of the fillet. Next. Okay. Now I'll use the transform place tool, and I'm going to place this curve, which is the chamfer angle, okay, on this plane, and I'll accept that. Move over here, grab this, accept the 2, and place it. Now we have our chamfer angle. Okay. What we need to do now is find out where this angle hits this point, right? So we need to find basically the 0 parting line, or where this surface and that curve are tangent to one another. We can do that using create a vector, and I'll just create a vector right here. Okay. And now I'm going to grab this surface and turn on my surface evaluation. Okay. Now, surface evaluation can show quite a few things. Here, I'm showing curves only, and I'm showing the 0 degree. We could show, and 0 degree is the parting line, right? We could show positive and negative draft, right? So if we zoom in here, there's the positive draft, there's the negative draft, and there's the exact tangent line where if we looked down this line, right, we would be finding the high point or the silhouette of that surface. Now once we've done that, let's create a draft surface, okay? And we want to create it on this line using a picked vector, okay? So that gets our angle, and I'm just going to build that at 0 degrees. So right now, if we do an evaluation and check the tangency, do we not have a COS there? Maybe that was not a curve on surface. Yeah, it's visual. Those two surfaces would be tangent, okay? Oh, I know. We don't have a curve to check against, so we need to project that on there. And now if we do a tangent check, our two surfaces are tangent, okay? And I'm just going to delete that COS that's on the draft surface. We don't need that. Okay, now, that chamfer's too long, so what I would like to do is get that chamfer trim converted right to where it's going to be used. So I'll just use the surface editing trim convert tool with intersect, and I'm going to use this surface intersected here and here. It shows me a couple of extensions need to be done to get it to trim convert correctly. And I'm going to save, oops, I'm going to save it in here. Okay, so that just created that surface. Now that's the proper chamfer. That chamfer now is the exact angle along this edge to this surface as this chamfer. The difference is that this chamfer is got its angle based on right where it becomes tangent to the high point of that fillet, okay? So that sets up our two control surfaces, okay? What do we need next? Next we need to put our transition in here. And this is where you could use blend curves. There's any number of techniques you could use to do this. I'm going to use a surface freeform blend. And just let's just reset this to the defaults. Yep. And I'm going to make a transition from here to there. Curvature's fine. I believe this is curvature. Okay, and we have our surface. All right. Now, we need to make that follow the whole structure of this surface. Well, this surface is degree 6. Okay. Now, it starts about the same place right here. And if we look over here where it ends, oops, it ends a little longer, right? So it's going to be difficult to line these CVs up since this surface is degree 5 and this surface is degree 6. So here's what I'm going to do temporarily. I'm going to copy and paste this, okay, turn my construction layer back on, and I'll template that. Okay. Then I'll grab this surface and change its order to 5. Okay. And I'm just going to use detach right here. And the reason I'm going to use detach is I need to get the end of this surface to be about where the end of this surface is. Okay, and I can delete this. Now I have a set of holes that's what a degree 5 surface looks like when it's about the same length as this surface. Okay, now what does that allow me to do? That allows me to come here and I can query edit this surface. Maybe I'll increase these a little bit, see what that does. We can do auto update if we want. Unlock these. Can bump that up. Oop, too far. Okay, so maybe we want to go there. Maybe that's as good as we can get without doing some manual editing. Now, I'd like this to be degree 1 in this direction, so I'm just going to set that to 1. Okay, and then I'm going to use my X-form control tools, slide, and I'm just going to, remember, we're doing this approximate, right? We just want this to look like it's got about the same hole structure across here, right? We need these to line up. Okay, that's going to give us the best opportunity for a good fit. Okay, when all these CVs line up, so when these and these line up, we get our best mathematical solution, I guess I would call it. All right, now let's get rid of this surface. That was just for construction. We'll pick our template and untemplate it. Then we'll increase this surface's order to 6. Okay, and we'll do the same thing. Now let's just move this around a little bit. This guy. Okay, and you don't have to do that interim stage where you do degree 5, but I find it works kind of nicely if you're able to get close with the degree 5. You won't have as many CVs to move. right? They won't have to be distorted as far. We're barely moving, you know, some of these now, a couple mils here and there. Okay, so now we have our chamfer surface. Next step is that we need somehow to get our transition from this radius size, so this radius and this radius, we need to get its transition to this radius, okay? And we'll do that using blend curves. And I'm going to put one blend curve here, and I always like to put on my geometry and be sure it's lined up. And I'm going to use this silhouette line that we made, okay, because that's where everything should be coming tangent, okay? I'll grab both of these because we're going to have to do the same thing here and try to line these CVs up. So I'm just going to go like that for now, get them close. Another guy here, lined up, and here. Okay, and we've got these control vertices. Let's pick that one and this one, and let's increase those a little bit, and maybe something like that. Okay, now we need these control structures to line up. So I'll do a hide unselected, and I'm going to put on holes for everything. Got a couple of curves here. They can have their CVs on. And let's just make these holes or curves degree 6. How did we do it? Let me step back a second. How did we just do this on the other side? We took this surface, copied it and pasted it, templated that. Took this surface, brought it down to 5. Okay, that's going to tell us where these control vertices kind of need to be. So we'll grab both these blend curves, turn their blend points on. We need to grab both of these, and let's make them go there, and something like that. This blend curve, stretch its control vertices to try to get them to lie on that same surface. This is going to make all of these curves and surfaces have similar control structures. That's important. If they have really different control structures, the math will get more complicated, or the geometry will get more complicated as we move from one step to the other. Okay. So I'm just getting these on about as good as I can. Now we don't need this surface anymore, correct? Grab this and untemplate it. Grab these two curves and let's make them both order 6. And you see there how it's almost perfectly on? Okay, that's what we want, and we'll accept that. Alt-O. Now those are our tangent lines, so I'm going to do an object display visible. Okay, those are now our tangent lines. So we need to project those on. I'll just do that with a quick normal here. Onto our chamfer, let's project these two tangent lines. Now we have a tool that's specifically designed for this case called Surface Fillet Symmetric Fillet. I know the tangent line that I want to use. I know the other side wall, okay? What this is going to do is generate the other tangent line. And if you notice, since we've worked out the angles correctly, we get a spot-on solution here, okay? Now we'd use this other tangent line, right? And the other wall, it points the arrow towards where I want to make it, and it generates the other side. Okay, so this side we might want to use edge align. Okay, and now you can see we're pretty close in these areas. Now we need to go back and do some continuity checking in here. But right now we've used those tangent lines to generate the other side of the fillet. So these are radii are varying based on the position of the tangent line I'm defining. Okay. So I'll grab these surfaces and stash them onto my creation layer. I'm going to grab my curves, okay, my planes, and my construction surface over here, and be sure those are all on my construct layer, and then turn that off, okay? Now let's do some continuity checking, just to be sure we're okay here. So if we check this continuity, we got a tiny bit of gap. Tiny gap there. Little gap here, okay? So we've got a little bit of problem of the calculation where this tangent line, when it came up with this, it was 0.003 millimeters off, okay? And on this side, 0.001 off from matching at these corners, okay? If we check on this other side, got a similar thing. Barely off, 0.002, and perfect there. So that side's okay. All right, so at this point what I would do is grab these tangent lines, okay? This surface needs to be untrimmed so that I can affect these tangent lines, okay? And what I'm going to do here is just use align, and I'm going to align that fillet, okay, to this fillet, and I don't want partial on, okay? Now I can see right here from the tangent check that's turned on that we've got tangency right now, okay? Now let's go over to this other side and do the same thing. So we have a curve on surface over here we need to correct too, so I'll delete that one. Object, edit, align, and let's align this fillet to this fillet. We want to do a partial here, but we want to be sure we're right at the end, okay? And again, we can see our tangent right here is okay. And the same here. So let's do this fillet to the controlling fillet, and we just have to be sure we're right at the end, okay? And if we query edit that, we can look at our tangency and we're okay. So now it's just a question of projecting a couple of curves on surface back on. Let's do a delete locators, and I just do a final check here. To be sure we're tangent everywhere. Curvature can be done in a very similar manner. Okay, it's the most important thing is this controlling surface, okay, and how you construct that controlling surface. So if we trim these up, now we've just constructed that corner. Delete my locators, okay, and we've got a really nice controlled surface right here that controls our chamfer. So now when a designer looks at this, or if it's my design, when I look at this chamfer, that chamfer is the same angle now, all the way around until that chamfer is gone, and then it simply becomes the radius, right? Very nice transition. Okay, and that's the 2-to-1 chamfer blend. So let's give that a try.